So ToPrimitive. ToPrimitive is, we're not going back to the Stone Age. What we're going to do is take literal values and turn them into primitive values. So a literal value in this case, like I have highlighted, is Tom, the string, T-O-M, or 30, the number, or false. We're going to turn those into string and number and Boolean respectively. So note that false and true are kind of funny because they're sort of primitive values and literal values at the same time, but when we see true or false, we'll turn it into a Boolean. So let's just take the challenge, and we have our one. I think there's only one test here. I added, because I'm addicted to challenge. I added big int and symbol in here as a sort of bonus. If we can make it pass without those, I think that's okay. But it's not that. It's pretty straightforward usually to add that part. So, all right, Chandler, where would you jump in on something like this?
Yeah, so I'm going to think through. We are going to ToPrimitive. I imagine, I know we're going to be recursing, because if we hit an object, we're going to pass it back to ToPrimitive to come in. So also another test that could be here is imagining we could pass a string to ToPrimitive, like just Tom, and it would return that primitive string as well. So that's an assumption that I think that we're going to hit. So we're going to have ToPrimitive takes an object T.
I'll make that case for you, actually. This is a good point you bring up. So like Tom, and then type B1, that would be B2, sorry. B2 equals string, and then type C2, expect, expect equal, and then we're gonna put in A2 and B2 here. And we should see, if we can make this test pass first, then we'll be somewhere.
Ideally, at least, yeah. So I think first we're gonna ask if T extends string. Ooh, not string constructor, string. Then
I'll format. Don't worry about the formatting. I'll get it
as we go. All right. Then we're going to return a string. Else we will keep going with our conditions. So like T extends number. Then this is gonna be number.
Yep.
Else if string extends. Nope, not string.
T. Yeah. I think we may have. Should we have passed? Wait. Let's stop at this one, and we'll see if we got C2 to pass, because it should by now, right? When you get this one.
Boolean. Else, and we'll say, I don't know,
never, just to stop. Yeah. Okay. All right. So we didn't we didn't wrap it. Yeah, we got to actually use the thing. Okay. Yeah. All right, C2 passes. So great. We are working. Okay, I can help you out. What would be the list of things we have? Don't hate me for deleting this. I'm going to put something back in a second. We have string, number,
Boolean. We'll get to the object and arrays, and then however big int and symbols used. I've never come across those.
Yeah, I mean, we could just try to. We could just do that, see what happens. What else would you put in here?
Undefined and null.
Yep, okay. Okay, so with that, ready for the dump. Here we go, boom. So I'll save you all the typing, and this one is weird. It doesn't actually fit on the screen. This is the one of the only breaks that I have to do of my usual formatting for the challenges. But it's like too many turtles down. So haha, here we go.
So if T extends object, then we're going to want to return an object, and it's going to be key, and I can never remember which of the two it is.
Yeah.
Key of
T, yep.
And then this would be ToPrimitive T of key for the object case.
Yeah, you just want to do this.
That's what it is. Yep, I always get the error and I have to Google it, and then stack over things as well.
Same. I'm literally the same.
It works. Like, why can't TypeScript be smart enough?
In the challenge, there's no way you would know this, but in the challenges, just because the built-ins call it P, in this case, we always just use P. But yeah. Okay. So, did you notice that all the tests pass?
The array one shouldn't. Why does the array pass?
Right. So this is a funny thing. Maybe I should. So after the challenges are all over, I'm gonna do some videos about like crazy things I learned while going through this.
Yeah.
And one of them is that they made a syntax where it's not really a syntax. Like here, let's do this, and I'll show you something kind of interesting about TypeScript. It's called a mapped type, and you can use it for objects. So like, let's say I did this. Let's say I had a type X, and it had like A, B, C in it, and I want to like add 1 to this. So I can do, let's keep moving down here, type Z equals text, text, and we pass in X. So what we see here is like, what would you expect this to have? What it has is A1, okay, this has to say and string, okay. So like this returns, this thing here returns a tuple, it returns an array. I mean, not an array, but a tuple. It looks like this shouldn't work this way. Like it looks like this is clearly returning an object, but it doesn't, because when you pass a tuple, there was a PR in 2018 or something where they were trying to figure out how to solve this, and they opted to do this instead of adding a new syntax to TypeScript. And so when you do a structure like this,
is an object with each item as a property on that object.
Right.
So they just hurts.
Exactly, because TypeScript treats tuples as like objects with values like 0, 1, and 2 as keys. So it like sort of makes sense. So they just excluded, there's a way to work around this if you actually want to get the array primitive, like the array prototype stuff out. But yeah, that's the reason that this thing works for arrays, is because of this fact. And it's kind of interesting. Let me show you.
It's interesting when they added in ES5 the map and filter in all those. Like it creates a new array, and then it uses object-defined property on the end indices to set the values because of
totally. This one I am so excited about. This one is like really, really, really cool. Check this out. All of these things that we had up here have dot value of, because JavaScript. Isn't this so clever? So what this is saying is, if it's an object or object, isn't this crazy? Like if this is an object or an array or a tuple or whatever, then we go through that same pass that we had before. But otherwise, we're gonna infer the value of like from value of, which is a function, and we're getting the return type. I was like absolutely knocked off of my chair when I saw this. This is such an interesting and clever solution to the problem, and it gets around having to do having to remember and name all the different types. It's just so cool.
It is future-proof.
It's future-proof as hell. Yeah, I mean, it's really, really neat. There's this one. And also, I should have mentioned this person, BOCBMOU on GitHub. This is their first GitHub issue ever. And they talk about starting strong. I don't know. Then there's this one. So this one takes maybe I should format it like this. This one takes a sort of interesting and different approach by using the mapping operator as well. And we should call this P if we're going to be consistent. Oops, different, capital P. Oops, is my caps lock on? Caps lock is on. Okay. So yeah, I mean, basically it's checking the 3 things that are in the test. It doesn't do big int and symbol, and then going through this way. So it turns out that because it's like a funny reality that we should, maybe if I bring back my other example that I have here, because if we what would happen, I wonder, if we pass in this value, we just get A back. Okay, that sort of makes sense. So what if we call value, anyway, we could play with it and probably get X to return A1 by just using an object here. It's interesting. So anyway, any other thoughts on these before we wrap up?
No, I don't think so.
It's pretty fun to go through the list like this, but all right, cool. On to the next one.